Welcome back to my channel. Hope everyone is doing well. Today let's solve Leetcode problem 3350 adjacent increasing subarray detection 2. Okay, this is an extension problem to yesterday's Leetcode problem. Okay, so let me just go through the problem statement once again. Given an array nums of n integers, your task is to find the maximum value k for which there exist two adjacent subarrays of length k such that both the subarrays are strictly increasing. Specifically, check if there are two subarrays of length k starting at indices a and b and where a is strictly less than b. Both the subarrays a till a plus k minus 1 and b till b plus k minus 1 are strictly increasing. Okay, the subarrays must be adjacent to each other. Okay, the first subarray and next subarray should be adjacent to each other. Okay, that means if the first subarray is ending at this particular index, then the next subarray should start at an index which is immediately next to it. Okay, return the maximum possible value of k. Okay, so whenever they ask me to find some maximum values, right, one thing that comes into my mind immediately is to apply binary search. Okay, here if you see, the k values can actually range from 1 till all the way till n minus 1. Okay, so idea is to get the maximum value in a specific range itself. Okay, when you want to get a maximum or minimum in a specific range which is in a sorted, which is already in a sorted order, okay, range will be in a sorted order, right? So when you are asked to identify a maximum or minimum in a specific range, then first thing you have to think about whether I can apply binary search or not. Okay, yeah, so idea is to apply binary search on the k. Okay, if you apply binary search on k, then you should be able to solve it. The reason being, if you see the constraints as well, the length is all the way up to 10 power 5. Okay, so you cannot in the yesterday's problem we have applied brute force algorithm, which is actually for each value of n and k. For the given value of n, we are actually checking each and every possible subarray starting at that particular index and checking whether there are two contiguous subarrays which was of length k, right? The overall time complexity in this was order of nk, whereas here if you see it is 10 power 5. Okay, you cannot apply the brute force algorithm, it will give you TLE over here. So if you apply binary search on k, okay, and if you are efficiently able to identify for a given value k whether there exist two subarrays for a given value k which are strictly increasing or not. Okay, the problem statement boiled down to, for a given value of k, can I identify are there any two subarrays which are strictly increasing. Okay, so let's take k is equal to 3. Okay, so yesterday we have done our algorithm in nk, right? Can we optimize this algorithm? Okay, yesterday the time complexity was order of nk. Okay, for the given problem statement. So for a given value of k, for the subarray, we were able to identify that there were two contiguous subarrays which are strictly increasing in this particular time complexity, right? Can we bring this time complexity to order of n? Okay, so let's look at this approach. Okay, so I have been given an array called nums. Okay, so this is the nums array, right? So let's have another subarray called increasing till. Okay, the increasing till is an array which will tell me that the number of elements which are increasing till that particular index, including that index as well. So since this is the first element, so there were no increasing elements before this, so increasing elements till this particular index is 1. Okay, since this is the only element I have. Now how many increasing elements I have which are ending at 5? Okay, so at 5 till 2 there were one increasing element. So since 5 is greater than 2, that means I can say 1 plus 1 which is 2. There till this particular index I have two strictly increasing elements, right? I am at 7. Till 5 I know there were two strictly increasing elements. Now since 7 is greater than 5, so till 7 I can say 2 plus 1, 2 plus the current element which is 1, right. So there were totally 3 increasing elements. Similarly at 8, since till this index there were 3 strictly increasing elements. At this part, since 8 is strictly greater than 7, so overall I have 4 strictly increasing elements till this particular index. Okay, see I will do this, I will populate the increasing tails in this particular manner. Okay, whenever I encounter an element which is not greater than this or which is actually equal to the previous element, that means this will be the again my counter will be 1, and that means this will be, there were no increasing elements before, this is the only element which is contributing to the increasing sequence. Okay, so that's the reason I will be populating it with 1. Okay, now that I have this increasing till array populated, so I have been said that for a till all the way up to a plus k minus 1, okay, and for a given b plus k elements should be strictly increasing, right. So b plus k minus 1, okay, elements in this range should be strictly increasing, and elements in this range should also be strictly increasing, where b is actually equal to a plus k, right. Okay, so we have been given these constraints, right. Now I know at a given index, I know there were actually these many elements which are strictly increasing. That means here if you see I have 4 strictly increasing elements till this particular index. Okay, since let's choose k equal to 4, okay, but here the increasing elements I have is 4. Okay, that means I can choose a part of it, okay, a part of this increasing sequence as part of my answer. So this is the entire sequence which is contributing to this 4. Since my k is only 3, that means I can only choose the previous 3 elements, right. If I choose, if my first subarray, if it is ending at here, that means from here you have to jump 3 more elements and see whether this particular, from here I am jumping 3 more elements, okay, and I have to check whether this element has 3 increasing sub elements or not, okay, which is ending at here. Okay, yes, it is having 3 elements which are increasing and which is ending at here. So these two are actually contributing to my answer if k is equal to 3. Okay, that means when I was traversing, I have to check at any given index, okay, if the contribution of increasing elements, if it is greater than or equal to 3, and the next index, okay, the current index plus k is also contributing at least k elements or not. Okay, so I can say if I choose an index I, okay, then increasing till of I should at least contribute k increasing elements, okay, right, and also increasing till of I plus k should also contribute k elements. Okay, then I can say that there were 2 subarrays which are contiguous to each other and both have strictly k elements which are increasing. Okay, for a given I, there has to be an index such that it has to satisfy both these conditions. Okay, so this way, if you see, we are utilizing an extra space of order of n, and we will be simply iterating through this increasing till array, and for each index we will be checking whether this condition is satisfying or not. Okay, so the time complexity will be reduced down till order of n, right, and the space complexity would be order of n. Okay, so now that I have an algorithm which will tell me that I can identify for a given k in linear time. Okay, if I if I apply binary search on a range where left is equal to 0 and right is equal to n minus 1, okay, so the binary search algorithm will actually take log n time, right. Now for each value of k I am applying this particular algorithm, which will be order of n. So the overall time complexity would be order of n log n, okay. So yeah, so let's look at the code now, okay, how the binary search algorithm have implemented. It's just a basic binary search, okay. So initially, as I mentioned, we have to populate this increasing till array, right. So I just define a variable called n, which is the size of the input array, and I have defined increasing till, which is equal to exactly the length of the nums array. Now I am iterating from 0 till nth element. For the first element, I have to populate it with 1. That means there is only one increasing element which is ending at that particular index. For rest all indices, I have to check whether the current element is strictly greater than or equal to its previous element or not. If it is strictly greater than its previous element, that means the current element is also contributing to the increasing sequence. So the previous increasing till plus the current element contribution, or else it will be 1, okay. So this way I am populating the increasing till array, okay. Now that I have populated this, now I have to apply the binary search, okay. So I have defined the constraints saying left is equal to 0 and right is equal to n minus 1, while left is less than n. My mid will be left plus right plus 1 divided by 2, okay. The reason I am doing this is we are actually looking for a maximum value, right. Every time you are looking for a maximum value, so we have to be moving towards our right every time, okay. So this plus 1 will actually contribute that at every given step we are actually moving towards our right, okay. So if left and right are both, if we encounter a place where we have to make a decision, and we have to make a decision, right, and our intention is to always identify the maximum value. So I mean the maximum value of k, and we have to go towards right. So that is why we have this plus 1 contribution over here. When you find the minimum, right, you will be having left plus right divided by 2, okay. So and I have a function called is valid, which will tell me the given value of k, can I identify any two subarrays which are strictly increasing and which are adjacent to each other or not. If yes, that means it is a valid answer for me, okay, but still I have to identify a higher value. So I will be updating my left to mid, and else my right would be equal to mid minus 1, okay. And yeah, so if you see the valid algorithm, all I am doing is to iterating through the increasing array and checking for each given index if the increasing till is greater than k and increasing I plus k is also greater than or equal to k. If this condition holds true, that means there were two adjacent arrays whose size is k, I mean two adjacent arrays where the contribution of increasing elements is at least k, okay. So if I run this algorithm, if you see, yeah, all the test cases were passed, and if you see the time complexity also, it will be order of n log n, and the space complexity would be order of n, okay. Yeah, that's all about this problem statement. This is like pretty standard binary search algorithm implementation. Yeah, that's all about this problem. Do subscribe to my coding channel for more such coding videos. I have seen people were watching my videos but not subscribing. I highly recommend you to subscribe to my coding channel so that you won't be missing my content, okay. I will be posting every day the coding videos, so it will be helpful for you to follow my channel. That's all about this. Thank you.